Day 4, our day 3 of our vectors unit, we're going to look specifically at adding vectors. Okay, so what your learning goal is to be able to add two vectors to identify our resultant. Okay, so why though are we adding or subtracting vectors? Okay, because sometimes you take a detour when you're traveling, but the final analysis, we are only interested in the final result. You've traveled from Waterloo to Toronto, okay? But you detour, but you only care that you went from Waterloo to Toronto. We want to know our final result, okay? So because we have multiple forces acting on an object, what's the final result of all those forces acting together? That's what we care about when we add or subtract vectors, okay? The final result, okay? So for adding vectors, there are two ways of thinking about adding vectors. They are almost essentially the same. One is called your triangle method, okay, or your triangle law of vector addition. The other is called your parallelogram law of vector addition, or your parallelogram method. Okay, so you just either think of it as a triangle, or you think of it as a parallelogram. Both essentially end up being almost identical, okay, but I personally like the triangle, but you will see the parallelogram a little bit in a couple of our like word problem type of examples, okay? So you just need to know what both are. So let's start with our triangle method for adding vectors, okay? So we're going to look at this triangle method first, okay? So easiest is to be given an example. So if we're given our vector v, so it would be northeast, and our vector w, which is east, okay? V plus w, so adding them together, that's the sum, right? Can be found by translating the tail of w to the head of v, giving, ooh, nice little annotation there, v plus w, right? So you're going to take the tail of w, that's the tail right here, okay, and you're putting it onto the head of v. Okay, your final result there is v plus w. Okay, make sure when you add, this is non-negotiable, you have to do this, you're adding head to tail. Okay, your resultant, or the final, so that v plus w, you'll be asked that in your homework, you'll find the resultant vector. Okay, so that's just that v plus w, that's your sum, okay, is going to be tail to tail. It starts tail to tail, so you'll notice tail to tail with the first vector, and then finishes head to head, okay? That is really important. I would like star these and write that down for when you're doing your homework, because sometimes you get confused on like where your final or your resultant vector goes, and you just have to remember you start tail to tail, finish head to head. Okay, you'll get used to that in some of our examples as well. Okay, so that's our basic for triangle method. What's our final result is a triangle. Okay, so for triangle method, we've created a triangle to which all of our standard trig applies. Okay, so we could use, if we want to use any of this, not 90 degrees, but we could use sine law and cosine law if we were asked to figure out any of those vectors, the length of them, okay? Or we could figure out our directions by finding any thetas or angles, okay? What if we chose to translate the tail of v onto the head of w? So rather than going v to w, what if we went in the opposite direction? No problem, the start and end points are the same. So if we actually went w first, okay, and then you're translating the tail of v, so the tail is going to go here, of v on to w, onto the head of w, okay, so head of the w, there's your tail there. What is your final result? Well, it's just v plus w this way, which means that the start and the end points are the same. Is it the same? Yes, it is. Okay, so it doesn't matter which way you choose to do it. Either way is going to give you the same endpoints, and the same resultant vector, which, excuse me, which is exactly what you want. Okay, now let's look at our parallelogram method. So if you know what a parallelogram is, just something that looks like this. Okay, two sides of parallel sides. Then you will be able to understand this method as well. Okay, so we're going to be given V and W. We're going to complete the parallelogram to find the start and end points of the resultant vector. Okay, so you have to take the exact same V and transcribe it up onto the head of vector V, and then you start with the tail there. So then you're going to get the top part of your parallelogram. You're going to do the exact same thing with our V. We're going to take the tail of V, put it on the head of W down here, and then finish at the head-to-head there. Okay, so you have created a parallelogram with your resultant vector V plus W. Okay, or you could label it as W plus V because it is the exact same thing. Okay, again, you would use trigonometry to determine the magnitude and direction. Realistically, by using this parallelogram method, you are just doing, we made this triangle first to begin. I told you making this second triangle was fine to begin. You have now just put two of them together for the parallelogram method. So they are almost the exact same thing. You're just putting two triangles together to make the parallelogram. Okay, so let's talk about the zero vector, and then we're just going to do an example. Okay, we look at what we call our zero vector. It just means that when two opposite vectors are added, the resultant, or the final vector, is the zero vector. So if you were to add AB and then plus BA is equal to 0. Remember that the absolute value of 0 is going to be 0 and the direction is undefined. So that's how you would state for a zero vector. Okay, if you were to draw it, it essentially looks like this, AB, but then you are essentially, like, I can draw it with a different color, but it's like identical on top of, it's like right on top of this, and it's going to go back in the other direction, BA. Okay, so that is how, because you have essentially not moved. Like if you walk 5 feet north to your to a desk, and then you walk exactly the same path back to a desk, you have technically, your vector is 0 degrees because it's like you didn't even move, right? Okay, that's essentially what that zero vector is. Okay, we're going to go through one example, and then we're going to give you lots of homework time to practice with adding vectors. So given vectors u and v, where the angle between u and v is 35 degrees, and the absolute value of u is 5, and the absolute value of v is 7, determine u plus v. Okay, so what we're going to do here is you're going to draw vectors u and v with an angle of 35 degrees in between them. Please note, when you draw a angle, you're going to draw it tail to tail. Okay, so that's kind of always when you draw an angle between two vectors, you're going to draw it tail to tail. Okay, so let's just say that we have u here, which is equal to 5, and then we're going to draw v here, which is equal to 7, and the angle between them, see it's tail to tail, is going to be 35 degrees. Okay, so what you're going to do is you're going to let's use our triangle theorem here, because you want to find out the resultant vector. Okay, because you're already given a diagram like this, it's easiest to complete the parallelogram. Okay, so remember, you're going to transcribe, so you're going to take the tail of u and put it on the head of v. So I'll try to make this as much like a parallelogram as I can. Okay, and then you're going to take the tail of v and put it on the head of u. And then, so you're going to complete your parallelogram like that. Okay. Then what you're going to do is you can figure out using our, if you remember, because these are parallel sides, right? So this is parallel to this, and this is parallel to this. So this is going back to like, I think it's grade, even grade like elementary school. We would have seen it a little bit throughout high school. You are going to use your C pattern. Everyone remembers your C pattern because it's parallel lines and you're able to find what this angle is. Your C pattern, those two angles add up to 180 degrees. So you can do 180 minus that 35 degrees to equal 145 degrees. So this is 145 degrees here, okay, using that C pattern, which then will help us because we're able to use cosine law to figure out, again, I'm going to draw in here. What color haven't I used? Let's go black, okay? So we're going to find our resultant vector. Sorry, that's just terrible. So we want either v plus u, because you've drawn both, or u plus v. So we want that resultant vector, right? We want u plus v, okay? So we can use this triangle now because we have lots of angles there and sides. So yeah, let's use that. So this is what we're going to find, that u plus v. Okay, we know this is 5, we know this is 7, and we know this is 145 degrees. Well, you have a angle embedded or contained between two given sides, so we're going to use cosine law. Okay, your cosine law, if we label label this, let's go, this is A, this is B, and this is C. You're going to find side B, so we're going to go B squared equals A squared plus C squared minus 2AC cos of B. Okay, so A squared is going to be 7 squared plus C squared, which is 5, minus 2 times 7 times 5, cos of 145 degrees, because that's what angle B is. Then from our very first unit, you will just do that math there. So I might just give a couple of short steps. Give me a second to calculate this. We're going to go 74 minus and then it's negative 57.3406.431 when you put that in a calculator. So make sure you keep the two negatives there. Okay, so you're actually going to add them together. So 74 plus the 57.3406.431. Remember, keeping more decimals just makes your answer more accurate. So you're going to get 131.34, and then you need to square root. So it'd be 11.5 rounded. Okay, and they just did absolute value, so there's no actual like units on the 5 and the 7. So you are just going to have to write a therefore statement. You're going to have to do therefore the absolute value of u plus v is equal to 11.5. Sorry, my computer is slowing down. Okay, so just make sure you have that that final statement there, because we did change this to like A, B, and C kind of for our own purposes for using the cosine law. So just make sure you have that final statement there that says that. Okay, so this is kind of more of like a thinking application question, which is good for you to get used to kind of the triangle method and the parallelogram method. And you will see this again later on in the unit as well, in the next 2 lessons, okay? So here's your homework. Just let me know if you have any questions. Make sure you, excuse me, make sure that you're understanding what adding vectors are. Subtracting vectors, which is our next lesson, is almost identical to that as well. So you should be okay if you understand one to understand the other. Okay, so just let me know if you have any questions. Good luck.